In this video, we're going to be looking at the algebra of functions. And so what I mean by this is functions are representing numerical values. You put an input in, that's a numerical value, and you evaluate and you get a numerical value as an output. And so since they are just numbers and representing numbers, you can actually perform operations on them like addition, subtraction, multiplication, and division. And then you can also do one other thing, which we will talk about, composing functions. But we're going to focus first on being able to perform the operations of addition, subtraction, multiplication, and division on functions. So we're going to look at a little summary. This is what we're going to look at performing these operations on functions. But before we do that, we're going to actually take a couple of functions, f of x, g of x, and h of x, and we're going to evaluate the function. Some people have asked for additional examples or more practice with this, and so I've decided to put a few more in here. So for each of these, we're told which function to use based on this letter, and then we're replacing our x value with whatever is in the parentheses. So this is f of -3. So I'm going to use the function defined as f of x equals x squared minus 3x plus 1. So in here, to do f of -3, I take the original function, and everywhere I have an x, I replace it with a -3. So you can see I actually kind of tried to color code this. Every time I saw an x, I replaced it with a -3. I put that -3 in parentheses because it's replacing the entire x value with the signed number of -3. And so I want to make sure that things like this exponent applies to the -3 and not just to a 3. So therefore, when I solve this, or evaluate this, I end up getting a -3 squared, which is 9, positive 9, because -3 times -3 is positive 9. Then we have this -3 times -3. So I think of the sign, that -3 as a -3 times a -3, which would give me a positive 9. So I end up getting plus 9 and then plus 1, which ends up being 19. So f of -3 equals 19. I'm going to wait a second and then erase so that we can move on to g of 4. So f of -3 was equal to 19. Now we're going to do g of 4, which equals the square root of 8 minus, we replace our x with a 4. So then we end up getting, we solve inside the radicand, or the radical sign first. So 8 minus 4 is just 4, so square root of 4, and the square root of 4 is 2. So this is equal to 2. The function of g evaluated at x equals 4 gives us a result of 2. This third one is a little different. We're evaluating f of a plus 1. So we have f of a plus 1. So what I'm doing is I'm replacing each of the x's in my function f of x and replacing them with a plus 1s. And I'm going to evaluate the right-hand side of this function and simplify it down as much as possible. So that means I'm going to need to expand and apply the squaring of this binomial. Then I'm going to need to combine like terms until it's fully simplified and there's no other things that I can combine together. So the first thing I'm going to do is take that a plus 1 and square it, which is going to give me a squared plus 2a plus 1. That's from squaring this. Then I take this -3 and distribute it to each part of a plus 1 here. So that's going to be minus 3a minus 3. And then I still have that plus 1 on the end. Now I can combine my like terms. I only have one a squared term. I have these a terms. And then I have the green circled constants. So I'm going to combine each of my like terms. So a squared, and then 2a minus 3a gives me negative 1a, which I just read as minus a. The 1 is assumed. Then I have 1 minus 3 plus 1. So 1 minus 3 is negative 2. Negative 2 plus 1 is negative 1. And so f of a plus 1 is equal to a squared minus a minus 1. Our brains are getting warm, hopefully. Our next one we're going to do is g of 10. So again, that's the square root of 8 minus x, but in this case our x is equal to 10. So I end up getting the square root of negative 2, which is an imaginary number because we can't take the square roots of negative numbers. We don't get real answers, real results from the real number system. We could say that this is the same thing as square root of 2 times the square root of negative 1, and the square root of negative 1 is defined as being I, an imaginary number, and so we could say that this is I root 2 if we wanted to, but we could just say it's not real. So you'll be given an option to indicate if it's not real, or if they tell you you're allowed to have an imaginary answer, you could write it as an imaginary answer. The next one is going to actually apply this chart from the top. We're asked to do and evaluate f minus g of negative 8. So what that means is we're just taking the two functions and subtracting them. And then we're going to substitute in our value of negative 8, and then we're going to simplify it down. So let me show you what that means. F minus g of negative 8. Well, our f is equal to, what is it? X squared minus 3x plus 1. So I'm going to write out the subtraction of those two functions and replace all the x values with a negative 8. Okay, I know that's a little squeezed, but that red little blob is a minus negative 8. So then when I evaluate that, I end up getting negative 8 squared is 64. Negative 3 times that, or minus 3 times that negative 8 gives me positive 24. Then I still have a plus 1. And then I have minus square root of 8 minus negative 8. 8 minus negative 8 is 16. We solve this using an order of operations. Technically, our square root of 16 is like an exponent because, and I'm going to do a little cloud on this left-hand side, or actually I'm going to erase some stuff, because when I have square root of 16, that's the same thing as 16 to the 1/2 power. So anytime I have a radical sign, whether it's a cubic root, quartic root, whatever, square root, we can treat that like an exponent when we're solving using order of operations. So I'm going to do that exponent or power first. The square root of 16 is 4. So it's 64 plus 24 plus 1 minus 4. 64 plus 24 is 88 minus 1 minus 4, because I got to make sure I bring everything else down. Sorry for skipping forward. Then 88 minus 1 is 87. 87 minus 4 is 83. So the answer to this, fully evaluated, sadly in this weird box right by it, is 83. In the next one, we're doing g times h of negative 8. So again, based on the chart up above, you can see that when we're multiplying our functions, we're just saying we're multiplying each function times each other. And then if we evaluate it at negative 8, we replace each x value, or x in that, with a negative 8. So g times h of negative 8, we're just multiplying these two functions together and replacing the x values with h. or sorry, negative 8. I don't know why I said h. Anyway, so we're going to solve this using an order of operations. We can think of each of these functions as being in parentheses, being multiplied together. So I can solve each part first and then multiply. So we have here square root of 8 minus negative 8. That's going to be the square root of 16, like we saw in the previous problem, times 2 over negative 8 plus 1, which is negative 7. So essentially we end up getting 4 times 2, or we can think of this as negative 2 sevenths, which equals negative 8 sevenths. Okay, you can think of the 4 as a fraction being over the value 1, because any whole number I can turn into a fraction by dividing by 1. And so when I multiply the numerators, 4 times negative 2 is negative 8, 1 times 7 is 7. Oftentimes it's better to just leave that as a fraction because I don't want to deal with a repeating decimal, and if I'm not asked to round to them, we want the exact answer, which is a fraction. Some things to note about your fractions. I moved this negative up to the numerator because if I have negative 2 sevenths, that's equal to negative 2 divided by 7, which is equal to 2 divided by negative 7, because all three of these are acknowledging that the number itself is negative. This one's putting it on the outside of the fraction, but saying negative 2 sevenths. If I think about this, negative 2 divided by 7 would be a negative number, and then 2 divided by negative 7 would be a negative number. So all three of these things are equivalent. So it's okay for me to switch this negative 7 to be in the numerator if it's easier for me to think of it that way. I could also have pulled it out entirely and thought of it as 4 over 1 times negative 2 sevenths. Okay? That would have also worked. All right, the last one is h of negative 1. So h of negative 1, which is just going to be 2 over negative 1 plus 1. That's 2 over 0, because negative 1 plus 1 equals 0. That is undefined. As I mentioned in a previous video, we are not able to divide by 0 because it defies the rules and the 0 property of multiplication. And so therefore this is undefined. It is not equal to 0. It is undefined. Okay. All right, so what this was an example of was evaluating functions and evaluating operations on functions. So we had some traditional examples, previous examples we've seen before, but now we have an added layer of where we're able to multiply functions together and evaluate. We're able to add functions together and evaluate, subtract functions together and then evaluate, and then so forth and so on. And so this is kind of a new twist on something we've done before. I'm going to stop this and have this be our part 1 video. Part 2, just a preview, is going to be looking at the domain of a function when we add and subtract functions or multiply and divide functions together. Please make sure to watch part 2 of the video. This one's probably going to be broken into a couple of parts just because there's a lot of information contained in all of this. Thank you.